Okay, we should be live now. My screen is shared. Yes. All right. So good morning, everyone, and welcome back again at our monthly query research progress update. The main goal of this team is the same as it was before. So in order to hide away the complexities for reading and writing for application developers that want to interact with decentralized knowledge on the web, we look into designing and analyzing efficient read-write abstractions for over decentralized data environments for interactive applications. So these are the people that are working on these topics. Not everyone is here today due to circumstances, but most of the people are. So the format is the same as before. So 3 slides per researcher. First slide for each person will be about the high-level goal of each research topic, then the accomplishments of the past month, and then the targets for the next month. And after each set of slides, we have a short moment of discussion. So let us get started with our first researcher, and that is Bryan.
Yes. So my IDLab goal is to optimize link traversal queries using explicit data publication structure. So in the main, the goal is to use data summaries that data provider could give inside of their, let's call it the network of publication, and also to use the URI path structure that they use to publish their data. And go to the next. So this month I've worked mainly on 3 things. The first one is to facilitating the querying of network of sources with heterogeneous vocabularies using simple rules. So in the previous month, I was able to have an implementation that worked without link traversal, and this month I've been able to make it work with link traversal. I've also started to do some unit testing of this implementation, and also to design a demo use case so that we could present it and maybe make a paper out of it. Because the second step will be to expand it to have a more expressive set of rules, but we first want to have something that is stable and that we can present a bit. The second objective was to work on creating an index for validated queries so that we can have the result materialize and redo those. And when we want to redo those queries or do similar queries, being able to use those materialized results, because validated queries can be sometimes really expensive and long to be executed. So what I focused on is the query containment aspect of it. So I've done a bit of literature review, and I realized that most of the literature assume a set semantic, whereas Sparkle is a backset semantic, because the Sparkle has a query language that's back semantic, and triple stores have a set semantic, and there is not a lot of contribution about that. I've also started to do an analysis of the semantic of the context of related queries, because it's a bit different in the sense that when we do service call, we execute a query to a remote endpoint, which is not the kind of operation that I really saw in the literature. And I've also started to do an implementation of one of the popular algorithms. And lastly, I've also started to do some rewriting of the paper I submitted to ISWC, and the rewriting is well advanced. So I've made some new figure and process the feedback. We can go to the next slide. So this month I'm planning to finish the unit test and the demo for the schema alignment project. I'm planning to create a good approach for the query containment problem in the context of validated queries. And I'm also planning to finish to rewrite the paper and to continue the implementation of my query containment algorithm. And that's it for me.
Okay, thanks, Bryan. Any questions? Bryan. How how do you define a good approach for your query containment?
Because we could technically just assume that it's set semantic, but it wouldn't really match the reality of it. So I'm trying to have an approach that actually match what's really happening in those systems. So that's why I said a good approach.
And what would be the problem? So you say that current approaches rely on set semantics, while Sparkle uses back set semantics. What would be the issue of you using pure set semantics based containment algorithms?
Because it's just not valid. It doesn't give the right result because the query that is contained with set semantic is maybe not contained with back semantic.
So it produce incorrect results, or like missing results, or too much results?
Yeah, just incorrect result. The query will just be faulty because if you have projection or certain operators, you just get less result in the main. So you think that it's contained, but it's not actually. The queries are not actually contained with each other. So it's just faulty.
Okay.
Because they do that because it's still a fundamental result. And if you don't have projection, don't have optional, and I don't remember which other operators, then they are the same. But if you have those operators, then it can, they are not similar.
Okay.
And
yes, Fabien.
Yep, just one quick question is, in your papers, you probably need to have baselines to compare to. So how did you set up your comparison with the state of the art, and what are your baselines?
For which paper?
The one you are writing now. I'm guessing. So as soon as you touch the domain of proposing a new federated query solving, some of your reviewer will ask you to position yourself with regard to baseline known in federated queries. So what are your baseline, and how did you set up your comparison and benchmarking with existing methods?
I haven't started to write a paper about the query containment stuff, but what I'm doing right now is that I'm re-implementing some of those algorithms. I would use that as a baseline, and there is some paper that have I've created some benchmark for query containment in the context of Sparkle. So I'm just trying to reuse them and to show that it's actually not a good. They don't give good results when federated queries are considered. So that's why I will propose, because my thing will mainly be an extension of an existing algorithm. I think this is my plan. So I was just going to show that it's not working in theory, it would not work also in practice, and then I would propose my extension.
But also there are two components to your comparison. There is the baseline method and the benchmark data. I remember a time where if you wanted to be the best federated query engine, you just had to find the best benchmark data for your engine, which is, it's a bit of a provocation I'm saying here, but at one point there were several benchmarks, and when you were looking at the results, the same algorithm were ranked differently on each benchmark, which was capturing the fact that depending on the complexity of the patterns you have, depending on the piece of the algebra of Sparkle you're using, some optimization may be good in one case or may be burdens in other cases. And so I was also asking what you had in mind for the benchmarking itself.
I haven't thought about it, because at least the way that I see it correctly, the way that I want my contribution to be is that in the current way that stuff are done, it doesn't consider real use cases, because they just make some big assumption about the semantic, and my contribution was more to say that now we can try to make it work when you use the actual real semantic of what is happening, and also to extend it for federated queries, which in itself I don't think it changed much consider that it's a federated query. I mean, there is some new operator to consider, but I felt like the main of my contribution was to have it in backset semantic. But I'm not far enough to. I haven't thought enough about the benchmarking of it right now.
Okay, thank you.
So the contribution is more theoretical than practical.
Yeah, to make magic theory the practice, I would say.
Yeah.
Because backset semantic query containment already exists. I haven't saw it really for Sparkle, but Sparkle can be expressed in relational algebra, so we know that it's probably possible. There's just not. I just didn't saw anything for query containment.
Okay, good. Let us go over to Maarten.
Okay, so my high-level goal is to optimize decentralized querying using aggregators with incremental processing. As always, aggregators are components in the ecosystem that pre-computes queries and make them available for other agents. And I want to update these query results with incremental processing. So if the data changes, the incremental processing makes sure that the query results stay up to date. So in the past month, what I've been working on is in the incremental query engine, Incremunica. I've implemented order by. Last month we talked about this, and yeah, I decided to actually implement it as I need it soon. This is mostly done, I think. The main thing is just testing and making sure that everything is actually covered. And then after that, I also did some improvement in the testing. So Incremunica is now tested on all platforms, so Windows and Linux and Mac, and also all the browsers. And I did some fixing there, and then also I implemented the user tools, as I've noticed that it's sometimes quite hard to actually use it because everything is very obscure or tucked away somewhere. So I made a collection of functions to actually make it easier to use in Incremunica. And then the second thing I've done is worked on a paper that we're planning on submitting to the Semantics and Data Spaces on. It's a workshop of ESWC. It's actually a paper from a thesis student that I helped, and it's on decomposition of queries. So the idea is to rewrite the queries and then decompose them into different subqueries and then perform these queries separately or in parallel. Why we do this is to actually make sure that the subqueries that they actually produce a decomposition, that multiple agents can actually better use these results. So making sure that there is less duplication if multiple agents require the same query, but just slightly different. That's the main idea of the paper. And the deadline for that is, I think, March, somewhere at the beginning of March, I think 6th of March. So that one is almost done. And then my next targets are to build a demo of the Solid Watch Party app and submit this to ESWC. This is more a demo of Incremunica. And then start on the aggregator journal. And for this, I actually have to finish the aggregator proof of concept and then build some use cases to be able to show how the aggregator works and maybe see some performance improvements over just not using an aggregator. But yeah, those are my next targets. That's everything.
Okay, thanks, Maarten. Any questions? I have a question regarding that query decomposition paper. Is it based on or related to the any of the algorithms for Sparkle federated queries? Because there's also a lot of query decomposition in there.
Well, the related work, I'm working on it now because it was actually not included by the thesis students, but I'm actually working on it now. And so it's related work, but it's different. The algorithms used are not the same, but it is related to it at least.
But what are your criteria for the decomposition, Maarten? If I give you a query, along which axis are you going to decompose it? Because there are many ways of decomposing.
So what the thesis student did was to actually do the most basic thing and or the most simple thing to actually recombine the results, and that's based on a union. So it will decompose the query on unions because the results of the unions are just combining the results. You don't need to do any further processing after the unions.
So it's a kind of disjunctive normal form you're doing on the query.
Exactly.
Okay.
And then we did some evaluation on the common benchmarks and extracted the unions out of them, and then seeing if the result set is actually smaller, or the materialized view or the query results are actually smaller than not decomposing. But yeah.
Any other questions? If
What's
not,
your just out of curiosity, what are your, so you mentioned the solid watch party as an application, as what are the, are you evaluating on any other benchmark again, the benchmark question?
I actually not sure if there is any benchmark. I guess solid bench is a possibility to run this on, but yeah, there isn't really a benchmark for aggregators or something similar. So probably for this paper not, but in the future, as this is more like a vision paper, I guess. If we go more in depth, probably we will need to figure out some way to actually properly benchmark this. But for now, it's just based on use cases and saying these are some use cases, and how is this ID actually, how can this actually help in the real world? And what's the performance difference then?
But then because you say it's based on use cases, any of these use cases would come with adequate data. I mean, what I'm asking, I'm guessing, is the elevator speech. You get stuck in an elevator with me. I ask you, what are you working on and what is the killing app? And you have 3 floors to tell it to me. What would be the application where you really need the aggregation, and therefore it would be nice to demonstrate it?
I don't know off the top of my head a few things when an aggregator is better than actually not using an aggregator, but the main thing is for complex queries and on startup times, for example, of the app. And a lot of actually applications do this right now. Look at Mastodon is a good example. They actually pre-compute your feeds before you actually access the app, because if you don't, you need to wait 10, 20 seconds, maybe longer, to actually have your initial view of the app. So you pre-compute this query. So if the app starts, you can immediately build your UI and start using the app. And afterwards, you can do some other queries, but the initial startup is important. That's a reason why an aggregator needs to exist in decentralized environments. There are some other use cases, but that's the one that I remember now.
Okay.
Oh, another one is, for example, Twitter. Hashtags in Twitter is a difficult query to do in a decentralized environment. For example, if you want to find all the hashtags of, I know, hashtag open for work is a hashtag. If you want to execute this query, you need to go over the entire network to actually figure out who has used this hashtag, which isn't feasible in like a normal amount of time. And for this, you can also pre-compute these queries and then make them available to speed up these queries, or not really speed them up, but allowing them to happen, let's say.
Excellent. You have your elevator speech now.
Nice, thank you.
all right, then we can go to Jonni.
Yep. So my high-level goal is to investigate adaptive client-side techniques to find ways to basically optimize query execution without relying on server-side implementations to the extent that is possible. Yeah. So within the last month or so, since the last stand-up, I continued working on the avoid support for Communica to avoid sending count queries to endpoints. if they provide a void description, and this actually now works. For example, for some of the example queries that we have from the people in Switzerland, the use of the void thing helps avoid sending any count queries at all to the endpoints, which is really nice, at least for most of them that I tested. I haven't actually gone through all of them. And it's especially helpful with the Wikidata endpoint, because sending a count query for something that just asks for all the labels in the dataset will time out always. So that actually allows the estimation to work for such patterns. But it has some performance issues that I'm working on, because it the way it loads the descriptions, or it's the way it tries to discover them, apparently ruins TPF, triple pattern fragments performance, because it tries to find descriptions where there are none, and it takes too much time for every single document that is fetched. And then I also finished an HTTP rate limiter finally, and it tries to match the request rate to the server response rate. So if the server only replies to 10 requests a second, then it sends 10 requests a second to that server, or tries to, and it tries to do it in a way that doesn't store any state by just applying delays to requests. So over time, it should, like if it is given enough time, it should do what it's supposed to do. And that one is finished. I just have to do some more testing to make sure that there are no performance regressions. And then I also fixed, or like I did a workaround for a retry with status 405 with retry after for PPpedia, because instead of 429, they send a 405. So now it's there by default if you use retries. And then also fixed the bug and submitted a retargeted join restart paper for ICWE. And that's what I did. And then my next target is to finish the void extraction performance thing as soon as possible. It's almost done. I'm planning to hopefully finish it today, because the previous one used queries over a set of RDF data, which was easy to implement, but it performs kind of poorly. So the new solution is to process a stream of triples, and that one is turning out to be a huge pain to implement, unless I make some assumptions on which order the triples appear in. Yeah, and once that's done, I will investigate the hybrid query execution over Solid and Sparkle endpoints, which is related to a project. And my plan for that is to initially set up a demo to get some performance benchmarks and numbers to see what happens if you replace some of the solid pods with Sparkle endpoints. And that's hopefully done soon. Still have to properly start on it. Most of the things are done from since almost a year ago now, so it shouldn't take too much work. And that's it.
Okay, cool. For the ICWE paper, has the deadline already passed, or?
Yes.
Yeah, okay.
It was.
When do you have news for that one?
Check. They postponed the deadlines by a week.
Okay.
So the deadline was last week, Thursday, and the original notifications are 3rd of April. I don't know if they will also postpone those.
Yeah, maybe a bit, but yeah, around the beginning of April. Okay, good. Any other questions for Jonni?
Yeah, I'm not completely sure if you could explain to me again what is happening with the 405. So the 405 is method not allowed. So when do you get that, and what is exactly the problem here?
Yeah, it seems that if you send enough requests to the DBpedia Sparkle endpoint, like more requests than you are allowed to, based on the rate limits, then instead of sending 429, they send a 405 with a retry after header. I don't know why, but that's what happens.
Okay, thank you. That clarifies it.
Have you contacted them already?
No, not yet. But it was easier to just add a workaround for communicate, like if there's a 405, but it also has a retry after header, then it treats it as a 429.
No, but definitely
Do you think it's a DBpedia thing or it's a Virtuoso thing?
I think it could be a Virtuoso thing, but I'm not sure because one of the errors seemed to come from Nginx. So I'm not sure if it's like if it comes from Virtuoso or if it's something about the rate limiting, if they have implemented it at a proxy level somehow in Nginx.
Yeah, that could even be at the hosting level because they may have Watchdog at that level. Okay, thanks.
Okay. The next person on the list is Jitse.
So my high-level goal is optimizing write performance in decentralized personal data ecosystems. So what I want to do is basically create an abstraction layer using Sparkle, such that you can interact with personal data ecosystems through the abstraction layer, so that you can say that you write to data ecosystem without having to specify exactly how. That was really vague. I'm sorry. Well, next slide.
Maybe try again.
Try again. Okay. So so basically what I want is that you, for example, have a solid spot and that you say I want to modify the state of this solid spot, and then that the abstraction layer handles the requests that are needed for this modification of status, and beyond the solid spot through the whole ecosystem, that you can have declarative queries that say what you want the state to look like.
No, so sending a Sparkle update query or doing a Sparkle update query over a solid pod with multiple documents and letting the query engine figure out where exactly the updates need to be.
Yeah. So that's the high-level goal. I worked on finishing my PhD symposium and preparing the storage guidance vocabulary demonstration. So for my the idea with the solid pod, which uses linked data platform, I implemented an approach there using a vocabulary called the storage guidance vocabulary, and that vocabulary was really document focused. But it did allow to make an engine that updated the documents such that you interpreted a solid pod as a collection of triples instead of a collection of HTTP documents containing RDF data. And I prepared a demo for that for ESWC. And then I also pondered some more about the semantic description that links data interfaces to the data that they expose. And I will be working on that instead of the storage guidance vocabulary. So the idea here is that I think you can make a description that more fundamentally works on the data level instead of working on document levels, like the storage guidance vocabulary did. And I want to actually create that, and doing that will allow us to describe interfaces outside of linked data platform interfaces, so that you can, for example, say that you have a solid pod, and you can write using HTTP queries, but then you also mention that there, and you can read from it, so it's a normal solid pod that you know, but it's also exposed through a Sparkle endpoint, for example, and using the approach that I want to work on, well, that I'm now working on, you could basically describe that the underlying data of these read interfaces, read HTTP interfaces, is the same as what is exposed through the Sparkle endpoint. Yes. And then I also, I implemented so I'm working on Dracula, which is transpiler for query languages. And last month, I already implemented the parser for Sparkle 1.1 and 1.2. And now I also implemented a generator so that, you get from the query through the abstract syntax tree, and now you can go back to the query. And I'm working, so that was done. And then I started implementing round tripping so that if you have a query and you make your abstract syntax tree and you then want to generate again, that you would get the exact same query, like the exact same string. And that requires still significant changes, since things like spaces and comments need to be counted. And also you normally have Sparkle is case insensitive, doesn't care about casing of your letters in most cases. And so if you want to have round tripping, you also need to basically start saving what the casing was of your parsed keywords. So
just on that point, just for me to understand, why don't you define round tripping modulo the insensitivity of Sparkle?
So the idea would be that in that we have the same like Babel does, for example, for JavaScript, where you have a transpiler, and so that if you that you could, I think, write in one version and then export to another, and then everything will be the same, except that translations that require for the transpiler have been applied. So I think it's a user, what's it called? It's for the user to make it pretty, I guess. But
okay, so I understand. So the reason why it matters is that although it may not matter from a semantics of Sparkle, the user may want to keep its capitalization, for instance, and that's the reason why you have to preserve it. Am I right?
Yeah, so that if you, for example, make a linter or something like that, that everything would still work correctly.
Okay, sorry for interrupted.
No problem. So that's that. And then next slide. So I still need to write a demo paper for ESWC, although that was mostly done yesterday. Then I want to release V1 of Dracula, but I'm not sure that will happen this month necessarily, or next month. Then I need to prepare the logistics for my research stay in the Technical University of Vienna. So the idea would be to work on the transpiling algorithms itself at the research lab of Katja Hoos. And I need to prepare logistics for that. And then I want to read up on RESTDisk and Hydra, not necessarily because, I want to research their benefits and their flaws in relation to that data mapping that I want to investigate on a data perspective instead of the HTTP, instead of the documents thing. And that's it.
Yes, Pierre-Antoine.
Yes, thanks for the presentation. I wanted to continue on Fabian's question about preserving presentation details, so to speak. I'm a bit wary of this being a kind of worm, although I understand your arguments. But then what about indentation? What about comments? It might bring you quite far. But if you want to go down that path, I would have a look at the specification of the YAML format, because YAML, maybe you have already YAML, allows comments, as you probably know, and a number of things. And there are several levels of parsing that are described in the YAML specification, depending on whether you are only interested in the semantics of the data or in preserving some aspects of the presentation. So it might be a source of inspiration for defining those different models and define what round tripping means.
Yeah.
To those models.
Yes, thank you. Yeah, it has been like, yeah, I worked out a way to do the round tripping, which I think is quite nice from a data perspective. Like if you have your abstract syntax tree, basically I append most of the result types are objects, and I append a key on the object RTT round trip type, and in that object I put all the metadata information towards round tripping, which is basically contains images. So it's like, yeah, it contains the images of keywords that you parsed, and it also contains a list of ignored characters, which is basically a list of either blank spacing or comments. But it works, but it's mainly a pain because you need to start adding in your grammar. You need to have now rules that actually parse the blank space itself. So it's a lot of it's not complex, but it's a lot of work because everywhere in every rule you need to start adding the sub rule to parse blank space. But I'll get there. Yes, Fabien.
Yeah. Question on the update part, the first part of your talk. So if I understood well, your problem there is to distribute an update on several sources, right?
Yes, depending on the definition of a source, yes.
And so my question was, do you cover all types of updates or specific types of update? For instance, can I modify all the first names of all the ladies? So it's an update where I use the where insert delete, or is it more like I want to modify the name of a given person, or both? What part of the update algebra do you actually target?
I think, but there's been no. Well, I had to work from a master thesis, but there's no additional work. I think both kind of updates work, but I do take a stand away from, for example, if you say a modify where, the where part is basically I view it as a read query, and so I kind of delegate the work of read queries away from my PhD work. So I say like there's already enough people working on read queries across, for example, these solid pods. And so I then delegate the reading, so the where, I delegate it to the read team, and then I will get basically a list of triples that need to be modified. And from there on, I will start looking at how to modify the triples or quads in the selected data store.
Okay, so let me rephrase to see if I understood. So you use the basic query mechanism to identify the bindings, and you rely on a tracing mechanism to know where these triples have been found and then to modify them. That's the case. You are able to trace the source for each one of the triples you have identified and must be modified. You have a provenance mechanism then to go back to where you mean to modify. Yes.
Well, yeah, that's yes for this discussion. Let's say yes, because it has to do with my thinking and cloud thingy where it becomes no. So for this discussion, let's say yes.
Okay. No further question.
I have one last question about the round tripping. Definitely keep an eye on the performance impact of that as well, because it might be that for some cases we don't need round tripping at all. So in that case, we don't need the overhead of parsing the comments and the spaces and so on, because I suspect that it will, impact performance. So we probably need a way to say to the parser, don't do that, so that things are a bit faster.
Yeah, I thought you would say that. Eventually down the line, I thought you'd say that. My idea is to implement it, to measure it, and then basically modify. The idea of the parser would be that it's very modular. So where I now have a single Elixir rule for parsing both comments and blank spaces. You would easily be able to take away that Elixir rule and insert another Elixir rule that starts ignoring the blank spaces and comments again. And then the parsing of the subrules that parse blank spaces could be, they wouldn't do anything. So either they would still have a performance impact in parsing nothing, or parsing nothing takes no performance impact. We'll have to measure that then, I guess. But even if it has a performance impact, I don't think it will be hard to make a conditional function on putting on whether the subrule needs to be called or not. So the biggest problem there would be to fix my types. Okay, I will see. Yeah, thank you.
Canonical Spark. Really interesting.
What is that? Yeah, we'll talk about it later.
I was just teasing Pierre-Antoine on the new standardization activity for Canonical Spark.
I haven't heard of it.
It doesn't exist.
It doesn't exist. That's the reason why.
But Canonical RDF exists. There's a spec for it, or I don't know if it's finished already, but I guess it's almost finished.
It's finished. It's finished. It has several official implementations.
Okay. Oops. There's my cursor. There it is. Okay. And that's all for today then. So the next time we meet again is on March 25th, again at 9:30. Before we close, are there any final words or announcements from anyone you would like to share? If not, we'll keep it at that for today. Thanks all for joining, especially Pierre-Antoine and Fabien. See you all next time.
Thank you. Bye-bye.
Thanks.
Bye.
Thanks, bye.